Problem number 10 on the quiz, we're going to convert to standard form and give the foci. So this is going to be an ellipse, and we're going to want to put it into standard form, which is like what we had in problem 9, where we have two fractions added together set equal to 1. So in order to do this, we're going to need to complete the square. The first step is to subtract the 189 from both sides of the equation. So negative 189 will be on this side. And then what we want to do is write our x's together. So I'm going to write 25x squared minus 150x. Then I'm going to put my y's together. So 4y squared plus 32y. Then I'm going to want to complete the square, but I can't do that unless I have x squared. So I don't want 25x squared. So I'm going to factor out the 25. And that leaves me with x squared minus 6x. So I just divide both of these by 25, pull it out. Over here, I'm going to pull out the 4. So that gives me y squared plus 8y. Now I'm ready to complete the square. So to complete the square, you take the coefficient of x, which is negative 6, cut it in half, so that's negative 3, square it, that's 9. So I'm going to add 9. But you can't just add a number to one side of the equation without adding it to the other side of the equation. But here's the trick. I didn't just add 9, I added, if I use the distributive property, 25 times 9, which is 225. So I have to add 225 to the other side of the equation because I added 225 on this side of the equation. Over here, complete the square. Cut this number in half, that's 4. Square it, that's 16. But I didn't just add 16, I added 4 times 16, which is 64. So if I add 64 on this side of the equation, I need to come over here and add 64 on this side of the equation. So now I'm going to write this perfect square trinomial as x minus 3 squared. And I'm going to write this perfect square trinomial as y plus 4 squared. And then I need to do the arithmetic here. So I have negative 189 plus 225 plus 64. And that's 100. Then I want to divide the entire equation by 100 because I always want to have a 1 here. So whatever this number is, that's what you're going to divide by to make 1. So divide by 100, distribute the division, put this into lowest terms. That's 1/4. So it's x minus 3 quantity squared over 4. Put this into lowest terms, that's 1/25. So it's y plus 4 quantity squared over 25 equals 1. So now the center of my ellipse is at 3, negative 4, and it didn't ask us for that, but I'm going to find that out so I can help locate the foci. So I've answered the first part of the question. I've put it into standard form. So now in order to locate the foci, remember the foci are going to be on the same axis as the major axis, which is this with the y, because this is the bigger number. So if you think about this as being located at 3, negative 4 with its center, 3, negative 4, then take 25 minus 4, which is 21. Take the square root of that, it's about 4.6. I'm going to be going 4.6 units up and 4.6 units down from this point, because this is my major axis and the foci is always on the major axis. So how I'm going to write that is going to be in the following way. So you're still going over 3 units on the x, but for y, instead of being at -4 for the foci, you're going to add radical 21. So -4 plus radical 21. And then you're still at 3, because you go over 1, 2, 3. But now instead of being at -4 for the foci, you're at -4 minus radical 21. Okay, so this gives us the ordered pairs of the foci. Problem number 11 on the quiz is going to use Heron's formula, which was covered in the video for lesson 6.2. So just a quick review, because you can watch that video again. Heron's formula is when you want to find the area of the triangle and you know its sides and you don't know any of the angles. So there is the formula. A, B, and C are the 3 sides that are given, and S is called the semi-perimeter. It's basically take the perimeter and divide by 2. Problem number 12 on the quiz will involve the area of an oblique triangle. That was in lesson 6.1. So this, just a quick review, this is where you can use half times BC times the sine of A. And it can be written more than one way, but you're essentially doing the same thing. Basically, they're going to give you an angle. They're going to give you the 2 sides that form the angle. And you take 1/2 times 16 times 24 times the sine of the angle that is included between those 2 sides. So make sure you're in mode degrees in your calculator and you'll be all set. In number 13 on the quiz, this is the last problem, you want to graph and locate the foci once again. So from 9.1, we have to put this into standard form. So once again, with standard form, we want this number to be a 1. So I'm going to divide by 144. Divide by 144. Divide by 144. So putting this into lowest terms, it's going to be x squared over 9 plus putting 144 into lowest terms is y squared over 16 equals 1. So once again, we have a situation where we are centered at the origin because there's nothing being added or subtracted to y. We've got the major axis in this particular problem as the y-axis again, and it's at 4 and -4 would be the vertices. So 1, 2, 3, 4, -1, -2, -3, -4. For x, take the square root of 9, that's 3. So we're at 3, -3. Draw your ellipse. And then to locate the foci, they're going to be on the longer axis, which is the y-axis. Just take 16 minus 9. That's going to be 7. Take the square root of 7. And since it's on the y-axis, x would be 0. So keep the x coordinate 0. So there are your foci. Then to actually locate them, go ahead and take the square root of 7, which is about 2.6. So it's about 2.6 positive and 2.6 negative. So approximately here and here will be the foci. And that's the last problem on the quiz.